Hey, welcome back to my porch, and today I want to talk about an issue that comes up pretty often. It's not a major issue, but it does come up from time to time in pin reviews, and I have brought it up myself and that from time to time, and that is the way that our pins are made. And there's two primary methods of producing at least the plastic forms on our pins, and there's a third one that is up and coming. And I just wanted to talk about those three different methodologies of manufacturing and some of their pluses and minuses of these different types of manufacturing. The first one is injection molding, and no doubt this is the most prevalent method of producing our fountain pens amongst other items in the world, but we're talking fountain pens here. The second most popular, well, yeah, I'd say the second most, at least that we talk about, is turned pins. And then the third, this up and coming type of manufacturing, is called 3D printing. And so let's go through each one of them, and we're going to talk about their pros and cons and which one is better. Or are any of them better, or are each of them better in some degree? Okay, so let's talk about injection molding. Injection molding is, I'm just going to read this because I got a bunch of stuff printed out and I don't have it all memorized up here, so, but it involves injecting molten plastic into molds. These molds are anywhere from very simple type of designs, or they can be very detailed designs. Injection molding involves injecting molten plastic into carefully designed molds prior to cooling and ejecting from the mold. It's a highly repeatable process that enables companies to create high volumes of identical plastic parts with good tolerances at low costs per part. Thus, its popularity. Where I work, in one of the rooms, they produce these, we call them cassettes, because they're about the same size as a, for those of you who remember what came after the 8-tracks, you had vinyl records and 8-tracks, and now you have these, then you have the cassettes, okay? They're about that size, and we have these huge machines that make these cassettes. Each machine makes 2 at a time, but yeah, so you have these two parts. You have the front part, the back part of this cassette, and the machine puts this together, and then in this side it injects this white pearlescence type of plastic into the mold. And this is a pretty detailed mold. It's a part of a medical device, and so with all kinds of little ports and all these little grooves and so forth. If you're familiar with peritoneal dialysis kits, sometimes they're clear. We have both. Primarily in the room I work, we have the white plastic ones. Anyway, there's all these details in there, and they have to be done to high tolerances. Otherwise, the flow of the fluids doesn't work properly. Okay, so these machines are able to put out a ton of these items. In fact, I'm thinking in a day's time in our one room alone, if we're putting out, I think I figured 25 totes per per shift. So we got 3 shifts. So there's over 11,000 of these cassettes that are produced in a 24-hour period of time. So they can really pump them out. So the advantages of injection molding would be that they allow the detailed forms and thus also consistent quality. So like I said, is all the details you want you can put in these forms. The more details that you have, however, the more expensive the molds, and they're talk about the disadvantages there. Injection molding is compatible with a wide range of materials, plastics, metals, and even rubbers and compostable materials as well, for biodegradable, compostable materials. It's an efficient process with repeatability and reliability, because it's same mold time after time after time, and as long as you have molten material going in there, you're going to have the finished product coming out. Now with us, you have to say that yes, it's every piece is not necessarily perfect. That's why we have somebody that inspects those cassettes and tosses, and we recycle the plastic and all that. But we toss them away. But so there is some waste. But and then it can allow for lettering. In fact, we have identification letters and numbers, so forth, to get which is part of the finished product mold with each cassette as well. So we know what machine each one of these cassettes comes out of, and so forth. So you can do that. You can put company names or person's names or whatever. You're probably not going to put a person's name, because unless you want it on every one of your products. Also finishes. You can have finishes from anything with a slick, glossy finish, or even a leathery look to it. And of course, colors, it just matters what color plastics you put into it, and probably you can mix the different color plastics and get swirls. I don't know, but the disadvantages are the startup costs are high, because it's costly to make these molds, and the machines themselves are huge. They're expensive to manufacture, to run. The second disadvantage is the lead time for a new product, because you're having to develop a whole new mold, and the molds are, as far as I know, are usually like a very thick, very heavy-duty metal type of mold that can withstand heat and all that kind of thing. And so get the molds produced can take a while and can be expensive. So the lead time, in order to, once from the design phase to we're ready to make a product, to produce a product, then that can be a little bit long because of the design and manufacturing of the mold itself. Another disadvantage is if you have design changes, then that requires, a lot of times it could require the design of a whole new mold, or at least a redesign of a current mold, sometimes, but typically you're redesigning the whole mold, and so that can be expensive, and again, the lead time to get that taken care of. So injection molding is overall a more inexpensive form of production, and it's used for mass production. I mean, you're putting out a lot of product, and thus cost per piece is going to be lower. Initial cost is high for the machines to produce those molds, but over time, cost per piece is much is pretty low. So that's why it's very popular. If you're going to have something where you're producing a lot, then that might be a good way to go. Environmentally, there's very little waste. Like I said, once in a while you'll get a piece that is messed up, and therefore you have to scrap that and recycle it somehow and so forth. But overall, the piece itself, when you do the mold, make the mold, and the finished product comes out, it's not like there's a bunch of scrap laying around. The second option is what we call turning. Now there's basically two different types. You can either hand turn on a lathe, in other words, manually turn a piece. That's what I do as a hobby, and when I make my pens, it's just manual. Or you can use CNC. That stands for computer numerical control. And that's a machine where you program this machine, and it takes the raw materials and loads them. I don't know, sometimes it probably depends on the situation. It may need to be hand loaded in some situations, but typically you're gonna load this machine. It's going to have these blades basically that turn it, and so the machine does all the turning. The advantages of CNC are that there's, compared to say manual milling, there's more precision. When I make my pens, my tolerances are a lot more than what a CNC can do. The CNC, you want a 15 millimeter barrel of a pen. It's going to give you 14 or 15, whatever you put in, millimeters for each barrel that it's doing. Whatever the program says, it does. Whereas me, mine will go anywhere from 14, 15. I shoot for 15. It may be a little more, maybe a little less, and so but it's right around there. So there's that advantage. It also can work with, be used with a variety of materials, plastics, metals, various composite materials. Affordability, it actually costs less than 3D printing. Apparently the equipment is not as much. And then you're not, as far as cost compared to injection molding, the equipment costs are a lot less for CNC milling than injection molding. Disadvantages are material waste. When you have 3D printing and injection molding, you're doing additive manufacturing. In other words, all you're primarily doing is putting product into the mold, and that's what comes out of the mold. Whereas CNC milling or hand turning too, it's called subtractive. It's a subtractive process where you're taking a piece of material and you're shaving off or cutting off material, and that goes into a scrap bin, and perhaps you can recycle that too. But so there's a little more material waste that way. Also, one of the disadvantages is getting trained personnel to be able to run and program these machines. Those kinds of trained people are apparently in high demand because there's such a low supply, and people wanting to, for the amount of companies that are wanting to produce with CNC types of equipment. Then there's 3D printing. Now this is a process that creates physical objects by layering material on top of itself. If you're going to make a tube, it's just going to layer each like a bunch of rings right on top, and they'll be very thin, seemingly unnoticeable rings as a layer, and then it could be that once they're done, there's a finishing process where it buffs out whatever ridges there are because of the layers. Maybe it'll smooth that out to where you don't see it. But so that's how they're made. They layer, and you've all probably seen videos of small 3D printing small objects to, I want to say they've even done buildings like a house. Somebody 3D printed a house, I don't know. And they poured concrete, I don't know. Okay, some advantages. Allows flexible design and allows complexity. In other words, you can get detailed with 3D printing since it's computer design, just like with a CNC. It's based on CAD programs that you can get very, very detailed with that. And you've seen 3D printed items, and yeah, you can get real detailed with them. There's rapid prototyping. In other words, where you develop the CAD design in the computer, and then boom, you got the prototype right there. Injection molding, you got to get the mold going, designed, and then so you got to wait on that, and then you and it's not like you could just put out one prototype and then try a bunch of prototypes. I mean, that would be expensive, but that may be a process that they have to go through if in the long run they feel like they're going to be producing a whole bunch, or as my mom would say, a whole bunch and a whole bunch of stuff. But 3D printing even more than CNC, because CNC you may have to change some equipment design as well, whereas 3D printing, all you're dealing with is the computer, and how this machine is going to lay out the product, the item. You can do print on demand. In other words, you can have a bunch of programs and program it to do 5 pins one way, or change, switch the program and do 5 pins another way. And you're not having to change a whole bunch of other stuff. You're just changing the program. It can produce parts for a variety of industries needing strong and lightweight parts. They make them for aerospace and just school supplies to aerospace, and so it's very useful in a variety of industries, which can be helpful. It minimizes waste, and therefore, another one that's more environmentally friendly, because it's just putting out the material that's going on the platform that's being printed on. So it's just putting out that material. The disadvantages is it's more limited to the materials that can be used. It can't, right now anyway, 3D printing can't use all types of plastics and all types of metals, so there would be a disadvantage there for 3D printing. Restricted build size. 3D printing, if you want smaller objects, it's a lot easier to do it. If you want larger objects, you either have to have a very large, a large machine, a large area that this machine can work with, or you have to have multiple machines making parts, smaller parts that get combined to make the larger part. So there's that disadvantage. And injection molding, that would be a similar situation. You know, it's going to be hard to make super large parts, and the larger the part, the larger the machine you're going to need, and so that's going to be added cost as well. For 3D printing, cost per part is going to be the same for small volumes as well as large. I mean, the materials that it takes to make one part is going to be the same as it's going to cost to make a bunch of parts, and it's going to cost the same to have somebody make this program for one part or for 10,000 parts. So let's see, part structures. Layers can delaminate under the stress of layered manufacturing. In other words, as it's making these layers, depending on the heat tolerances and the heat fluctuations and so forth, sometimes those layers won't combine as tightly as well, and thus after a while during the manufacturing process they'll split. And I'm kind of wondering, you know, maybe this could even happen out in the field, that if the layers don't combine, they'll delaminate. They could delaminate, I wonder, over time. So on our pins, you know, you're sitting there using a pin, is it going to make that structure weak? In other words, if it falls, is it going to be more apt to fall apart? So anyway, those are just the three general types of molding processes. Again, injection molding is probably the most popular, and CNC. I know that Edison pens, they use a CNC process of milling their pins, turning their pins. You get some bespoke pins companies out there where they're doing a very limited quantity, and so they're just, a lot of them are just hand turning like I do their pins, and that's why they're so expensive, because it takes time to actually do these, you know, turn these pins, and with all the threads, doing their own threads, and I don't do my own threads, at least at this point. And so yeah, it's, in my opinion, it's worth what you're paying for in some of those pins anyway. So and then 3D printing, there's a couple of companies I guess that or a couple of people that are actually working, already producing some 3D printed pins, and that, you know, that may become a more popular method of producing some of our pins. So anyway, I'm gonna you know, now take you into my office, and I'm gonna show you an example of some turn pins and some injection molded pins that I have. And then at the end of this video, or toward the end of this video, I'm going to surprise you with a manufacturer that you might not have thought of, that uses a particular process in here, and you're paying a whole bunch of money for their pins. So so stay tuned, okay? All right, so I'm going to show you some examples, and I'll be right back. Alrighty, I have three pins I pulled out that are transparency type pins, colored, but transparent nonetheless. And just to kind of go over some indicators that a pin is injection molded or turned acrylic or plastic, whatever you want to call it. Some are very obvious. If you take a look at it around as I turn the cap here, see those little ridges there? Those kinds of facets, if you will, and as well, and in particular, this little nib at the end there. See that? Okay, there, you can see it really good there. Okay, that shows that this was the port that the injection was made. Now this is on this little tip here, but obviously that's screwed into this part of the cap. So these are two different sections basically. But if you look at this part of the cap, you'll notice those facets as I turn. See right there by my big fat thumb. Okay. That indicates that this is a turned acrylic. And then I don't know how well this is going to show up. Right about here, somewhere underneath there, you're going to see this little line. And sometimes sometimes they're very obvious. Other times, if you get a loop, you can see them. On this one, it wasn't too hard to find, but there's a line there. And then on the threads, there's another line. I think I have it pretty well in focus. I think you can kind of see it right around there. Anyway, and then there's a line over here, a separate line on those threads, and then there's another line somewhere around there going the length of the body. So there was three different sections of this line, of these lines going down through the body, the grip section and the body of the pen. That is also an indication of injection molding, as far as I have been able to determine. And so when you see those, you know those are dead giveaways. Now, other pens, such as this P136, this Asvine P136, you might see some. In fact, I think on this pen, the only lines I could tell, it doesn't have the little injection molded port right here. And then as you turn it, I couldn't see any lines. Now, it could be that those lines were just, they did a good job polishing out the lines, but you don't have those little ribs or facets in there to show strength and whatnot. And this is not an insert, I don't believe. I believe this is where, and I've done this on pens that I've made too. If you're wanting to give strength to different parts of the pens, or you just don't need, in this case, they were trying to make a place where that grip section would seal off. And all you'd have to do is either put an insert in there or use a smaller drill bit to go down the length of the pen, and then a little bit larger one to come up to that. That may be what they did there, but I wasn't able to see any indication. I can't swear to that. Now on this grip section, there was a line, and depending on how the light is hitting, I think it's going right along there, as well as to these, the threads right along there. There's some lines. But when you come up, or these threads, these smaller threads, so all along the grip section there, that looks like it was injection molded. You get to these threads, which is part of the body here, you don't see those. You don't see, and in fact, on the finial, you can tell, you see that little spot in there, that's where a drill bit kind of came to an end. And so of course this part's going to be a little separate, is going to be separate anyway, separate piece and all that, but I couldn't find any lines in there anywhere. And again, you'd use one drill bit for this section, another drill bit for this section, right in here. So you can do that. Now, again, I can't swear that these things weren't injection molding, but the signs of an injection molding aren't there. Now, one of the things that I look for too, if when I was really looking for this, is to find the lines in the threads, because it's easy to polish out lines in the other parts of the body, but in the thread section it's very, very hard to do. So that would be an indication of a turned pin. And of course, these two pins that I made, they're definitely turned, and so you're not going to find any lines, any nib points or anything like that anywhere. So yeah. So anyway, let's see, there's those. And then here's something. Now, I'm going to mention another brand here in a minute, but you may not believe it, but it's not just cheap pins that are injected molding, because you have here the Pilot 823, the Venerable. And with this pin, you can see, if you look in the cap there, you can see some facets right along there. Now, those come in handy because they're going to be holding that insert in as well. But they are there. Now, I'm telling you, you don't see any lines on here. So, but the grip section, let's see, the grip section has a line somewhere about there. And then hopefully I can pick this up. If you can see in the, okay, see those two little marks there right above my thumb? You get a loop. In fact, there's part, now this is separate from this part. And I think the line from here is right about there. So, but those little marks there, yeah, you can see them a little bit better. That's indicating right there that there was part of the line. And if you take the loop, you could just barely see the extension, just a tad of an extension. So you can kind of see that rough part there. That's why I'm saying you can't buff out all the lines from the threads. But Pilot did an excellent job in doing what it could, because when I have my loop, I don't know if you may be able to see that there a little bit. Anyway, there's a little bit of line coming off there, but it doesn't extend down there because they've polished it enough, apparently, to get rid of that. But it's there, and so you know, it just goes to show that even expensive pins can be injection molded. Now sometimes I kind of wonder, because like this tip here, or the finial, and I'm not going to take this apart to try to figure it out, but in this finial too, do not have the injection ports. But I'm kind of wondering, because this pin brand that I'm going to mention in the next section, they don't have any ports either, but they are injection molded. So I'm not sure if there's sometimes the port is interior. And you know, like I said, I'm not an expert on molding processes and all that. I just know some of the stuff that I'm acquainted with, but parts like this I'm not sure of. But anyway, so I just wanted to kind of give you that example, and again, it doesn't really matter. I mean, there's so much more to what goes into the quality of a pin than whether it is injection molded or, anyway, yeah, so this one didn't look like it had marks for injection molding. These two definitely do. This one, very easy to pick out. This one, not so easy. You had to really, really look for it, except for those facets or ribs in the cap there. Alrighty, well, we'll continue on with the next segment. Alrighty, Well, I appreciate you taking the time to watch this. Now, I told you about a pinion manufacturer that uses a particular process that you might be surprised at. And like I said, we tend to think of turn pins as being the highest quality, and I'm guilty of this too. And we think of injection molding pins as being cheap things, you know, they're mass produced, whereas turn pins are produced at smaller quantities and so forth and so forth. They must be better, they must have greater quality to them, strength and so forth. But that's not always the case. In fact, I showed you on that custom 823 that I had, that's an injection molded pin. So it's a high quality pin, but it is produced with injection molding. Another pin that you might not be aware of is Mont Blanc. Yes, those Meisterstrucks. Mont Blanc pins are produced via an injection molding process. Now, here is the difference, and here's where the quality comes in too. Again, how you design these injection moldings, where the areas that you're strengthening within the pin, that all matters, but also the materials that you use. They call it precious resin. Now, I don't know all the chemical makeups of all the plastics that are being used. The Mont Blanc resin is going to be different than, say, you know, the Jinhao X159 resin that is used in producing that. They're both the same process, injection molding, but they use different types of materials in their processing, which, you know, is debatable on whether you think that really is worth the extra price. But anyway, there you go. So the process really, the bottom line here is the process doesn't matter. What matters is the final product. And so you're not going to hear me, from here on out, you're not going to hear me say, well, this pin, it's injection molded, or this pin is a turned pin. You're not going to hear me say that, because it doesn't matter. What matters is, does that pin hold up over time? Does that pin write the way you want it to write, you need it to write, the way you have to make it worth the money that you put out for this pin? Is this pin performing for you for the purposes that you are going to use it for the amount of time that you are going to use it for? Is it working for you? That's the bottom line. Not the process, it's the performance. Thanks for watching. You have a great day.